So today we are going to be looking at scatter plots. This should be reviewed from Math 8. So what is a scatter plot? It's just a set of points that shows the relationship between two different sets of data. So we can have a positive association, and this one would be a pretty strong positive association because my points are clumped tightly together, and you see as the x values increase, the y values also increase. So as we move left to right, it's going up. That's a positive association. This would be an example of a negative association. So you see as my x values increase, my y values decrease, but this one we would call weak negative because these points are a lot more spread out. You could have no association, which means as you look at the points, they're not going up, they're not going down, they're just kind of all over the place. Or we could have a nonlinear association. So these are grouped together, but instead of grouping together in a linear pattern, they're grouping together in a nonlinear pattern. Okay, there are a couple other things that you can look for in scatter plots. So first is an outlier. An outlier is kind of like a point that doesn't belong. So it's a point that just doesn't fit in with the others. It's kind of like the outsider point. So an example would be if we said, let's take the average age of the classroom. So everyone writes down their age, as long as you're sitting at a desk. Well, if Mrs. Stroll is standing up as I ask you to do that, all of your points are going to be very closely related. You're all very close in age. But if I went and sat in a desk, my point would be much higher, way off from everyone else's. I would be the outlier. Then there's also clusters. So if you see points that are grouped together, those are called clusters. So it's just a group that lives very close together. And then in between clusters, oftentimes you'll see what we call our gaps. And those are just areas that contain no data at all. All right, let's go ahead and look on the inside. So now we're going to try to come up with a line of best fit. And we can use lines of best fit to predict things. So for example, when you were younger, you would go like a baby. You would go to the doctor and they would always weigh you, measure your height, measure the circumference of your head, and they would keep that data. And by the time you're teenagers, they are using a scatter plot and a line of best fit to predict how tall you're going to be when you quote unquote grow up. And so that is just one example that you guys are probably used to. Back in the old days, I still remember my doctor opening up the manila folder and there was a graph on the very left-hand side with all of my data and different lines running through it. And as I got older, where mine clustered to, the doctor said I was going to be somewhere between 5'6" to 5'8". I ended up 5'7". Now your doctor comes in with a laptop, but it still is doing the same sort of information. All right, so first thing we do is for a line of best fit, you draw it through the middle of the data. It is not going to touch every point. It is not necessarily going to go through all the points, but your goal is to make sure that you try to get it so that however many on the left of the line, there's that many on the right-hand side of the line. Once you've drawn that, then you're going to find 2 points that are sitting on your line of best fit. So I'm telling us we're going to use these 2 points, 502 and 2008. So those are 2 points sitting on my blue line. From there, I'll find my slope. Once I know my slope, I can then plug it into point slope form. So I just used the point 502. I plugged in the slope, I plugged in the point, and now I'm just going to change that equation into slope-intercept form. So now I have an equation for my line of best fit. Okay, same thing here. I'm going to draw in my line of best fit. I will identify 2 points that are sitting on the line. So I've identified the points 2014 and 122. From there, I'm going to find the slope. So y minus y over x minus x. I go ahead and do the calculations. I simplify it down. Okay, now that I know the slope, I'm going to put it into point slope form. I use the point 2014. Then I'm going to distribute, and then I'm going to isolate y so that it's in slope intercept form. So that's how we can come up with equations for our lines of best fit. All right, next up, how accurate that equation does at making a prediction can be determined using this thing called a correlation coefficient. And so we don't have to hand calculate these. We have technology graphing calculators. They're amazing. And the closer the R value is to +1 or -1, the stronger the line of best fit matches the data. And so you can say that this line is going to do a much better job at predicting. The closer the R value is to between 0 and 0.5, positive or negative, the weaker that is, and the less likely you're going to be able to say, yeah, this line of best fit is going to help me make a accurate prediction. So a R vector that is negative just simply means I'm looking at a negative association. And R vectors that are positive means I'm looking at a positive association. So now what we're going to do is we're just going to go ahead and, oops, I clicked the wrong button. We are going to go ahead and try to match these up. So if I look, which of my two positive lines has the stronger correlation? And hopefully you guys are going, Mrs. Stroll, this one is stronger. So this would be an R factor of 0.9. And then my other positive one, this one would be 0.4. Okay, now we're going to do the same thing for the negatives. Which one is closer together? And you're going to say, okay, this one is negative 0.9. And then this one is negative 0.4. All right, so now we have a graph that's been graphed for it. It says Silver City's experienced severe drought conditions. As a result, the depth of Silver City Lake is changing. This scatter plot shows the data collected by the local scientists. It also shows the line of best fit, and it gives us the equation, y equals -1/2 x plus 25. So which of these statements is true? The depth of the lake is expected to decrease about 2 feet every 1 month, or the depth of the lake is expected to decrease 1 foot every 2 months. Well, you have to remember that slope is y over x, and my y is the feet, and my x is the time, which is months. So a -1 would be 1 foot, and the 2 on the bottom would be 2 months. So this one is doing a better job of describing the situation that we're looking at here. Okay, let's keep going. So last but not least, we can use our technology, graphing calculators, in order to help us create a line of best fit, find the correlation coefficient, and determine how well this is helping us to match that data. So that's what we're going to do next. You can literally just type in desmos.com and you'll get the graphing calculator. I am going to go ahead and in this PowerPoint, and then I am going to pull up. Okay, so what I did was I went here and I added a table, and then I just entered in all of the data points. And then I came over here and I said I want my x-axis to go from 0 to about 8, and I labeled it as number of hours. And I said I wanted my y-axis to go from 0 to about 80, and I said that was the score. And then once I got it, I just kind of zoomed until I was happy and like, okay, I can see the score, I can see the number of hours, I can see all of this data right here. Okay, to get my line of best fit, I can type in y, and then if you look up here, it says y sub 1. So I can then say, okay, I want to do y sub 1, and then I'm going to say approximately mx sub 1, and then I can put plus b. And once I type that in, it is going to give me my slope, it's going to give me my y-intercept, and it's going to give me my correlation coefficient. And so this is saying it's doing a very good job of predicting this this is going to be a good line of best fit with an R value of that. Okay, Desmos has also updated it, so you can also click right here and you can say, okay, I want it to give me and you have all these different options. Well, I see that my data is very linear, so I'm going to say I want the linear, and then you don't even have to type in that Y. You're going to, again, it's going to go ahead and put the slope and the y-intercept right here for you, and then again, you can see it gives you that R value right there, showing you what the correlation coefficient is. So from that, we can use this to fill in the last part of the notes foldable, where you can say, here is the equation, here's the line of the correlation coefficient, and we can say that this line is doing a good job of predicting the data set. And that's the end of today's topic.